So, hey everyone, I hope all of you are doing good during this COVID-19 crisis and taking care of yourself. This is Akshay. I am a senior cloud engineer working as part of the Cloud Solutions Group in the company called Presidio. So, today we will be talking about Terraform. But before that, I would just like to mention that this entire event is possible because of the Tamil Cloud channel. And I would like to give a huge shout out to that channel because they have been giving a lot of content over the last few years for cloud related technologies as well as DevOps related technologies. So please do subscribe to that channel and learn a lot of content for free. And it's an amazing channel. So please do go ahead and do that. So, but we are here today in order to learn about Terraform and how to do it the right way in the industry, as well as how do you test your Terraform code, as well as go ahead and do some fun things. So let's get started and understand as to what Terraform is. We have two demos today, and we'll be here for at least an hour to hour and a half. And you will also be learning about the Terraform Associate exam. I recently sat that exam, so I'll be able to give you a lot of views in regards to that exam. But always remember to yourself, hardcore practical knowledge is any day greater than doing certification. So just keep that in the back of your mind and we'll get started. So Terraform is an infrastructure as code based tool that is used to create infrastructure across cloud based platforms. So that's the reason why you in all of these slides you'll have a lot of buildings related pictures because we are going to build an infrastructure. Okay. So today's agenda will be split up into these categories. So we will learn what is Terraform, the infrastructure, the introduction to Terraform. Then we will go ahead and learn about Terraform providers. And then we will learn about Terraform modules. We will learn about Kitchen and how it does the orchestration and how helpful it is for us. And then we are going to learn about InSpec, how we will be able to test our infrastructure. And finally, we will have an introduction to how the HashiCorp Terraform Associate exam is all about and how do you crack that exam, what are the right resources in order for to do so. Okay. So let's get started with the introduction to Terraform. So the intro to Terraform is that Terraform is an infrastructure as code based tool that is used to provision and manage any cloud related infrastructure or service. It can be AWS, it can be Azure, it can be Oracle Cloud, it can be VMware. You can use it to provision resources across multiple cloud based platforms, even your on premise infrastructure. So each and every cloud-based platform, if you think about it, they have their own infrastructure as code-based tool. So they have a cloud formation for AWS. We have a resource manager for Azure. We have deployment manager for Google Cloud. But then all of these services are only native to that respective cloud-based platform, but wherein Terraform is available across multiple cloud-based platforms. So it gives you a lot of advantage, and any new service that is released by any cloud-based platform, it is being supported by Terraform first, and then you will probably be seeing it supported by that respective cloud-based native service itself. Okay, you can define your infrastructure as code, which means it works in the background as I believe a Go language has been used in the background to write Terraform's libraries, but then you can go ahead and write code in HashiCorp configuration language called as HCL. It is very easy to understand. Extensive documentation has been created by the people at HashiCorp themselves. So it's very easy for you to write your entire code just by referring a lot of documentations. You can also take a look at Terraform registry, which is a collection of a lot of modules for different services such as EC2 or S3 or load balancers, or any service that you see across cloud-based platform will probably have a module in Terraform registry, which makes your life more easy because someone else has already written those code for you. So all you need to know is how to call that module and deploy that service. So you can create new resources, you can manage existing resources, you can also destroy resources that are no longer needed just by using some basic commands, which we'll be seeing in the next slide. So Terraform also provides you with an elegant user experience for operators, which means that this is a very beautiful feature of Terraform that you can in fact plan before applying your code, which means you will be able to see whether your infrastructure will be properly created before you actually create it. So that is called as the Terraform plan stage. And then you go ahead and deploy your infrastructure by using the Terraform apply command. So Terraform provides you that feature wherein you can just take a look at how your infrastructure would be before going ahead and actually applying it. Okay. So let's go ahead and learn about some Terraform commands. So the first command is called as Terraform init. So the Terraform init command, it's all about initializing your code, checking whether your code is valid, getting all of your modules that you have probably referred in your code, and initializing your providers. And we will learn about providers in the next slide as to what it's all about. So let's say, for example, that you are going to connect yourself to an AWS account. You're going to connect yourself to a Microsoft Azure account. You're going to connect yourself to an Oracle Cloud account. In that way, you need some kind of API calls that needs to be done in order for you to create the resources in those accounts, right? So that's where providers come into play. And Terraform init downloads that provider for you from the registry. So if you're using the AWS provider, you will be able to connect yourself with the AWS API resources that you're going to provision. If you are going to download the Azure provider, you will be able to go ahead and deploy infrastructure to Azure cloud environments and so on. Terraform plan, like I mentioned before, is a stage wherein you go ahead and take a look at how your infrastructure is going to be before you actually apply it. So it's taking a sneak peek, and this can be in contrast and compared with CloudFormation's chain set. If people have worked with CloudFormation before, you can create a chain set and see whether you are the resources that are going to be deployed before actually deploying the resources. So that's what Terraform plan brings you. You have Terraform apply, which actually creates your infrastructure. You have Terraform destroy, which destroys your infrastructure. You have Terraform refresh, which refreshes your state file with your actual infrastructure. And I'll show you this once we work with state files. You have Terraform validate, which validates your code and actually does a linting on your code to check whether there are any syntax errors and so on. You have Terraform show, which shows your entire infrastructure that has been created, and it displays your entire infrastructure from the state file. And in a moment, you will get really good clarity as to what a state file is. Terraform format is used for pretty printing. If you want to just do some indentation and all that, you can use Terraform format just for readability purposes. You have Terraform state, which is used for advanced state management. If you want to list all of your resources within your state file, if you want to go ahead and show your entire state file, if you want to move a resource to a different resource block in your state file, you can use Terraform state for that. You have Terraform workspace. And now this is like a very nice environment. Like, let's say, for example, you're working in your organization and you have dev environment, you have QA environment, you have stage environment, you have production environment. You can have different state files for different environments if you go ahead and use workspace. So it's like an isolated environment that you get wherein your Terraform code is being managed. So I can switch between workspaces by using the workspace command. I can use Terraform workspace select dev. I can use Terraform workspace create dev for creating a new workspace. And I'll be able to work with my code only in that workspace. So that means my state files will be stored only in that workspace. So these are all the different Terraform commands, and mostly we will only be working with the init command, the plan command, the apply command, and the destroy command. The rest of the commands, we may not work with it on a frequent basis, but then the initial 4 to 5 commands will be what you will be using. And most of the time, you may never need to do refresh, because refresh is already done when you do Terraform plan or apply or destroy. Refresh is done in the background. Okay. So let's move on to understand about, okay, so one last command, which is Terraform version. So which version of Terraform you're working with, whether it's version 11 or version 12 or version 13, which was recently released to general availability. So there is a huge difference between 11 and 12. So if you are writing your code in 11, always ensure you use the Terraform upgrade command in order to upgrade your code to 12, and then only you will be able to upgrade your code to 13. And this is done, on your behalf in the background. They in fact remodify your code, and it's a very nice plugin that you can use in order to modify your code from Terraform 11 to 12, because there could be some features that you would like to use in 12 which are not there in 11, right? So there may be some bugs in 11. So therefore, when Terraform, our HashiCorp releases version 12, you can use the upgrade command in order to upgrade your modules from 11 to 12. So we have Terraform providers. So provider is responsible for understanding all of your API interactions and exposing your resources. And why this is necessary is because, let's say that you are interacting with an AWS infrastructure, which means literally every call that you do is an API interaction. So let's say that you're creating an EC2 instance, you're creating an S3 bucket, you're destroying an S3 bucket, you're updating the configurations of an S3 bucket. All of these are API interactions at the end of the day. So there are multiple different ways that you can talk to your AWS account. You can directly log into your AWS account through the console and do everything just with your keyboard and mouse. You can use a programming language like Python or Java and the related SDK or software development kit in order to interact with the AWS environment. You can use your CLI in order to interact with the AWS environment. You can use Python's Boto3 library in order to interact with the AWS environment. You have so many different ways in today's world wherein you can interact with an AWS account. And one other way that you would do that is through Terraform for creating your infrastructure, which in the background uses providers. So providers is your business logic. So most of the providers configure a specific infrastructure platform. So that means you would need to initialize a provider using the Terraform init command for AWS. You may need to initialize a provider with the Terraform init command for Azure in order to interact with the Microsoft Azure platform. Providers can also offer basic local utilities. So there is a very nice provider called Random Provider, and this Random Providers allows you to create a random password, a random resource name, and so on. So let's say that you would like to keep things unique. And one example that I can give over here is you create an S3 bucket. S3 buckets are always DNS global and unique in terms of its name. So you can always use the Random Provider in order to create a random name for your S3 bucket. So in that way, you can do a lot of local tasks in your Terraform code because Terraform supports a wide variety of providers, not just only AWS, Azure, or GCP. You can go through their documentation and see that they support a lot of different providers, which they have split up across different categories. So major cloud platform has a lot of set of providers like AWS, Azure, GCP, Oracle Cloud, and so on. Then they have some providers like Random Provider. They have external provider, which is used for data external blocks. You have RabbitMQ providers for different services. You have Kubernetes provider. You have Helm provider. So many different providers are supported by Terraform. So Terraform registry, it's the main directory of where you can find these publicly available providers. And then you can go ahead and when you do Terraform init, automatically all of your providers are downloaded into your code, into your local environment. And I can show you this once we do the labs. So now let's take a look at Terraform modules. This is very important because any code that you write in today's world for any company, don't write it as a mono repo. Don't put everything in a single file. Start thinking about modules, reusable code at the end of the day. So let's say you are going to see this example and you will understand very easily. So modules are small reusable Terraform configurations. So let's say, for example, I am writing a tags module, and this tags module, I love to write this tags module because I can now reuse this module across different instances that I create. So let's say, for example, I create an EC2 instance. I call it as instance 1. I have one more instance called instance 2, instance 3, and instance 4. So now what I can do is I can go ahead and use this tags module in all of these instances rather than creating my own tags related code in each of these individual instances. So in that way, this tags module over here is a small and a reusable Terraform configuration that I can invoke from other modules. Like I can probably have an instance module, I can have a load balancer module, I can have a RDS database module, and so on. I can still reuse these tags module over there. So that's how you start writing Terraform modules. So let's say, for example, me being Akshay, I am developing a Terraform module, and that Terraform module is to create an EC2 instance. So everyone over here knows that when you create an EC2 instance, you need to give an instance type and as well as an AMI ID. And these are the two required parameters. You have to give an AMI ID as well as an instance type. So now what I do is I keep these both as variabilized parameters, which means anyone can enter their own respective variables. And then I publish my module into the Terraform registry. Now, all of the participants in this YouTube live session, you guys can go ahead and clone that from the repository or just point your source to that Git repository's URL. And then you can enter your own variables for the AMI ID as well as the instance type. And you can go ahead and create an EC2 instance for yourself. So now you are just calling a module rather than writing your own code, which is in one way reusable and very simple. So now what I'm going to do is I'm going to show you how it's done. Gordon Ramsay is my favorite person. I learned a lot of vegetable cutting from this guy, but let's go ahead and do Terraform right now. Okay. So I'm going to shift my screen to my command prompt. But before that, let me show you the code in VS Code. Okay. So let's go to VS Code. So in this VS Code right now, I have one basic module over here, and then I have another module with variables. Okay. So let me just go ahead and show you the Terraform code as to how to do that. But before that, let's go back a little bit. let's understand as to how to download Terraform in the first place, and let's start let's learn as to how to work with it. So let's open up Google Chrome and let's go ahead and do Terraform download. And when you do Terraform download, you land up in terraform.io/downloads, and you go into this specific website and you scroll down until you reach your respective OS level configuration that you would like to choose. And you can choose 64-bit for Windows. It's gonna download an exe file for you. So let me show you that exe file. You can go to my F directory where I have that. Under the software uh, directory, I have this exe file of Terraform. And now what you have to do is you have to go ahead and execute all of your Terraform commands, right? But if you have Terraform downloaded only in this particular directory, you will be able to execute Terraform only from this directory, which is not that useful for me. I need to execute Terraform commands from any directory. So for that, what you have to do is you have to open up your environment variables and then go ahead and take a look at path. And you can see over here we have f:\software added over here already. So all of your executable files within your f:\software directory will automatically be recognized, and now you will be able to execute Terraform code from anywhere. So step 1, download the executable file. Step 2, place it within a directory in your local desktop. Step 3, go ahead and add it to your environment variables as a path. And when you add it, now you will be able to execute Terraform commands from anywhere. Okay, so let's just execute a simple Terraform command to just check the version. Okay. Let's open up my command prompt over here and let's do Terraform version. And when we do Terraform version, you'll be able to see that we are using version 12.29, and after this the next version was 13, but I would like to stick with 12.29 for today's labs. But when you guys download the version 13, you can still start coding with version 13, and version 13 has a lot of new features. You will be able to do dependency between modules. You can do depends on modules. You can do count and for each. For people who are familiar with for loops in programming, you can do count and for each for modules. It's pretty interesting, the latest features. You can even do validation, which is pretty cool. And I'll show you later as to what that means. But for right now, let's stick to Terraform 12 and let's go through our Terraform code. And I'm going to execute certain commands and show you how it's done. So first, let's take a look at the code. So this is Visual Studio Code. You have a lot of different plugins that you can use in order to validate your Terraform code, or extensions as you would call it in VS Code, even for linting purposes. So let's first take a look at this module. We only have 2 TF files over here. So for anyone who is brand new to Terraform, you have to just write your files as .tf files, and then you are set to go. Okay. So let's go ahead and take a look at the providers.tf block. The providers.tf block over here has a provider called AWS, and we have mentioned the region over here as US-East-1. But then we have one more provider block over here, and now this is where providers become more interesting. So you have an alias block for a provider over here. Now alias, as we know it, is an alternate name. It's like the AWS provider is also known as. That's what you call an alias as. So we have another alias provider over here, which is the similar one, which is AWS provider, but then it has the alias of US West 2. And when it has the alias of US West 2, you can see that the region over here is given as US-West-2. Now what I can do, the reason why I use the provider alias over here is for you guys to understand that I can create infrastructure in 2 different regions just by using alias. How amazing is that? Does CloudFormation have this? Hell no. CloudFormation does not have it. That's the reason why Terraform is excellent. Like, you would love working with Terraform on a daily basis. So now what this means is when you do Terraform init, it's going to initialize your provider, and it's going to ensure that you have an alias provider over here, which is given with the configuration as US West 2, and you have an without an alias name provider over here, which is specific to the region of US East 1. Now let's take a look at the next file, which is the ec2.tf file, which creates our ec2 instances. So let's go to ec2.tf. It's very simple. It's a simple resource block copied twice with an output block. So I wanted to show you all of this today. So now let's take a look at the resource block, the type of the resource. Remember this will be asked in the exam. If you're attempting the exam, the resource type is AWS_instance. The resource name is my EC2. For people whom it's not that visible, I'll just zoom in a little bit. Yep. So resource type is AWS_instance. Resource name is my EC2. There are only 2 mandatory values over here. The 2 mandatory values are the AMA ID as well as the instance type. The rest of the values that you see in the Terraform documentation will be optional values. These are the ones that are required. And you'll be able to see this when you go through the Terraform docs itself. Okay, so let me just show you that in a moment. Let me go to the browser. Let me go ahead and type in Google. This is the way to search in Google. And always remember, the way you search in Google determines your salary. So let's do AWS underscore instance Terraform. And when you do this, it immediately takes you to the resource block. And in your resource block, when you scroll down over here, you will be able to see that the AMI is a required parameter. And when you scroll down a little bit more, you'll be able to see the instance type is a required parameter. Everything else is an optional parameter. Okay. Now let's go back to our code. So in our code, you can see over here that the AMI ID is predefined, which means it's not a variable. It's like hard coded over here. And this is the AMI ID for US East 1. And this is the AMA ID for US West 2. How would you get this? How would you get this? You have to log into the AWS console. So let's go ahead and do that. Let's do aws.amazon.com. Let's go sign into the console. For people who are not familiar with the AWS cloud, don't worry about it. I'll share an amazing resource at the end of this lecture. You can get a lot of knowledge from that. Okay. So I'm going to sign in as the root user into my own AWS account, which I use for my initiative. So once you're logged into this account, go ahead and choose the service called EC2. It falls under compute. You can find it under services over here. You can search for it over here. You can also search for it over here. You can also check over here. Click on it from here. So there are 4 different ways that you can find EC2. So AWS is that user friendly. So when you land into EC2, when you go ahead and click on launch instance, always think to yourself like which region you are using. The region that you are using over here is Northern Virginia region, which is US East 1, which means when you click on launch instance, take a note of the AMI ID. You can see over here, this is the AMI ID that I can see, and this is the AMI ID that I can see for Amazon Linux 2. Let's go back to our code and see which one we are using. So this is 09D8B. So we don't see a 09D8B, right? So let's do one thing. Let's change it. Let's go ahead and copy this AMI ID and let's modify it over here. So we have modified the first AMI ID. Let's go ahead and do it for the US West 2 region, which is Oregon. So I'm shifting my region from the top by just clicking on the region flag over here and changing it to Oregon. Now you can see over here, we have the Amazon Linux 2, which is this is the AMI ID for that. So let me go ahead and see which one I'm using, 067. Okay, so it's not that. Let's go ahead and modify that. So let's do Amazon Linux 2 over here. Let's copy paste it. Okay, cool. So now we are sorted out with the AMI IDs, which means when we create the infrastructure, we are going to get one EC2 instance in US East 1, one EC2 instance in US West 2. But how do you denote that it's going to be created in US West 2? You can denote that by using the provider block with the alias flag. So how you would refer this? The provider name dot the alias name. So if I go back to my providers file, the provider name dot the alias name. So that's how you would refer over here when you want to deploy a resource to that specific region. And then we have our outputs block. Now our outputs block is like, I'm going to get the public IP of the first instance in the US East 1 region. I'm going to get the public IP of the second instance in the US West 2 region. And how do I get this? By just directly referring to AWS instance dot the resource name. That means the resource type dot the resource name dot the attribute name. And how do I know this is one of the attributes? Let's go back to the Terraform documentation. At any points of time, you have to always come back to this documentation. Let's take a look at the attributes reference. When you scroll down over here, it's public underscore IP. If you guys can see this, it's public underscore IP. So it's public underscore IP. So that's how you refer to an attribute. So now what happens over here is once your 2 EC2 instances are created, then the respective public IPs will be displayed in the output block. But this is how you write Terraform code on the basic level. So you have a basic resource block, you have outputs block. Just to show you the the power of a provider, I have used the alias block for the provider. But now let's go ahead and see as to how do we test this out, right? So we have a test folder from within which we have a file called as ec2 underscore module, where we have a module block. And this module block is directly referring to our local directory, which is dot dot slash, which is one directory before, which means it's this specific directory. Okay. So now over here, the way we are going to go ahead and refer to the output blocks is we are specifying the module name as well as the output name. So if you can see over here, it's module dot the module name. The output name is nothing but the output name of your output variables that you have. So that's how you refer to the outputs over here when you're doing a module call. So now let's take a moment to talk about this source directory over here. This source can either be something in your local directory, it can be pointed to your GitHub repo or your Bitbucket repo if you're using source version control with a specific release tag. Like it should be a tag that is called as release-1 or release-2 and so on. Or you can also point it to Terraform registry. And when you point it to Terraform registry, a version flag over here is very important. It's a mandatory parameter. So you have to specify a source as well as a version if you're using Terraform registry. If you're using a local directory, you can just go with source. But if you are going ahead and doing it to a Bitbucket repo or a GitHub repo, you have to point your source to that Bitbucket repo or your GitHub repo's URL. So there are three different ways that you can call a module. So now after we have written this module, let's go ahead and see as to how to invoke this module through basic Terraform commands. So let's get started. I'm going to go into that directory. I have opened up my command prompt over here. Let's go into the directory Terraform labs. Let's go into the directory called lab3, which is the one that we are doing right now. And we are going to go into the folder called test. And from here is where we are going to do all of our Terraform commands. So let's learn the first command, Terraform init. So it's initializing the modules. You can see what it's doing in the background. It's initializing the modules. It's initializing the backend. If suppose you have a remote backend. So let's say that you can use S3 as a remote backend. You can go ahead and store your state file in your S3 bucket. And in a moment, the state file will become clear to you. And I'll tell you what it is because it's the most important file in all of your Terraform's configurations. And it also initializes your providers. So you can see over here, it has already detected the AWS provider with the latest version. So let's go back a little bit and take a look at it. So if you take a look at your providers, did you mention a version over here? You didn't. You didn't mention a version, but you can also do that. You can mention a version and you can lock down your provider to a specific version. But if you don't mention any version, it automatically downloads the latest version from the Terraform registry. Okay. So let's take a look at where it's stored. So you can take a look at the .terraform folder over here, within which we have registry.terraform.io, from within which we have the latest version of the Terraform provider as a .exe file that has been downloaded to your local directory. So this is where you'll be able to find your providers. Okay. So now let's do the next command. Let's go ahead and do Terraform plan. So Terraform plan is very important, right? Because now it's going to give you an idea as to what's going to be created. So it's doing a Terraform refresh also in the background. And it's going to tell you that there are going to be 2 instances that will be created. Okay, that's cool. Okay, so I think it already has 2 instances, which means I would have already tested it before. So it's going to just go ahead and replace the instances. So that's what you get. That's the knowledge that you get from Terraform plan. You will be able to see whether the resource will be created or whether the resource will be destroyed or whether the resource will be replaced, which is pretty cool, right? You get that insight from Terraform plan. But now you can ask me, how am I connecting Terraform to my AWS account? That is also very important, right? How do you even connect it? That's where the IAM service of AWS comes into play. So let me go back a little bit and show you as to how that works. So there is a service called as IAM in AWS. And this is a service that allows you to create credentials in order for you to access, in order for you to do API calls to this AWS account. So you can see that I have created a user. I think it's the CLI user. And this CLI user has administrator access policy in this AWS account, which means this is God mode. You will be able to do literally anything in this AWS account with this policy attached. But then how do I get the credentials? That's where the security credentials tab come into play, where I have my access key ID and secret access key. But obviously I'll not be able to see the secret access key over here. I can show you that in the CLI. So for people who haven't worked with AWS before, you have to install the AWS CLI. And once you install the AWS CLI, you can do the command called as AWS configure. And when you do this command, it's going to ask you for an access key ID and a secret access key. So let's do enter. We have an access key ID being asked. I have already populated it, which is the 75GY that is ending in. And the 75GY is part of the CLI user. So you can see over here, it's part of the CLI user, which means this is the credential that I have given to my AWS CLI in order to connect this particular system or this particular command prompt terminal to the AWS account. And this is what Terraform is using by default. And for security reasons, since this is a YouTube live session, I really can't show you the secret access key. So please pardon me for that. But the way that you would do this is in 3 steps. Download the AWS CLI, go to your command prompt, do AWS configure, go ahead and enter your access key ID and secret access key that you have created in IAM, give that user administrator access policy or even any granular policy that you would like, and then you will be set to go in order to execute Terraform commands to that respective AWS account. Okay, so let's do a control C. Okay, so now let's do Terraform apply. Since we have already done a plan and we are able to see all of our resources over here, so it says that 2 instances needs to be destroyed and recreated. Let me go to the EC2 console and see what it's talking about. So let me go to services. Let's click on EC2. So let's see whether there are already some instances that are running. Cool. I do have one instance that's running in the Oregon region, and I do have the same instance that's running in the Northern Virginia region. So let's take a look at that. So I have shifted my region to Northern Virginia on the top. Yes, there is one instance that's running. So now let's go ahead and do Terraform apply. What it does is it destroys these instances and recreates them. So let's go ahead and do Terraform apply from our command prompt. Let's do enter. So it's going to do Terraform refresh. It's going to do plan once more. And then it's going to tell you, it's going to ask you for a confirmation whether you want to go ahead and actually create your resources. So let's take a look at it. Okay, so now it's going to ask you to enter a value. I'm going to go ahead and enter yes, and it's going to go ahead and create a brand new resource. That means it's going to destroy those 2 EC2 instances and create 2 new EC2 instances for me. So since it's destroying the instances, let's look at it live on the EC2 console. Let's refresh in Northern Virginia. Please do remember we are in Northern Virginia over here on the top, and you should be able to see that the TF instance is shutting down and it's going to be destroyed within another 10 to 15 seconds. And the same goes for the Oregon region too. So you can shift your region over here on the top and you should be able to see that it's also shutting down in the Oregon region. So let's wait for a moment until it shuts down, and then you should be able to see that you can create 2 new instances. Okay. So this is terminated in the Northern Virginia region, and now it's creating 2 new instances. So it says destruction is complete for the previous ones. Now let me go ahead and create 2 new instances for you. So let's go ahead and do a refresh. Amazing. So we have a brand new TF instance over here in the Northern Virginia region, and you have one also that's being created in the Oregon region. Okay. So let's wait for a moment. It should, okay, so the Oregon region is already running, which is pretty cool. So let's just wait for a moment until these are created. So maximum 30 to 35 seconds. Beautiful. And we have our public IPs. How crazy is that? That's what you get from outputs block. So I'll just walk you through the output blocks once more. In your base code of ec2.tf, you wrote your outputs block, which refers the respective public IP of your 2 EC2 instances, which you also referred in your module call over here. So that means all of your outputs that are being generated from here in your output block are automatically passed to your module's output block, and you are able to go ahead and mention it over here. How amazing is that? So you got your outputs, you have your EC2 instances created, and now is where we are going to learn a little bit more about the state files. Let's take a look at the state file. So you should obviously have a state file over here within your test folder, within the .terraform folder, within, so you should have a terraform.tf state file. So this TF state file is very, very important because it has all of the properties of all of the instances that has been created. So we have 2 instances that are created. Let's take a look at it. So the first EC2 instance's name, let's find out the name. It's called as my EC2. Let's find out the second one. The second one's name is my EC2 US West 2. So that means this TF state file is very crucial for you. Don't ever go ahead and modify this file. Always store it in a remote backend such as S3 with encryption enabled and state locking in DynamoDB. But please, please, please don't modify your state files at any point of time. You can even delete the infrastructure in your AWS account. That's perfectly fine. But don't go ahead and modify your state files. So what happens? Let's say, for example, I'm just going to show you one thing. I'm going to delete the state file right now. I'm just going to delete it. I'm a very bad person. I'm going to follow really bad practices right now for the next 1 or 2 minutes. I'm deleting my state file. Now what's going to happen is Terraform literally has no clue of the instances that have been created. So now if you go ahead and execute Terraform apply, now Terraform is like, man, I don't have the state file. I have literally no idea what's been created. Let me just go ahead and recreate them. So now Terraform is like, I'm going to just add 2 more instances for you. because Terraform really does not have the brains in order to understand if you go ahead and just delete your state file. So let's go ahead and do Control C for this, because I'm not going to create two more EC2 instances and incur a lot of cost. What I'm just going to do is delete these EC2 instances. So instance state, terminate instance, terminate, and same that goes in the Northern Virginia region. So that's the dangerous aspect of deleting a TF state file. So never, ever, ever, ever delete a TF state file. Okay, cool. So let's take a look at one or two more other commands. So if suppose, let's say for example that you don't follow some kind of indentation and all that, and you want some really nice readability in your Terraform code, and you want it to be formatted for pretty printing, you can just go ahead and do Terraform format, FMT, with hyphen hyphen recursive flag to do it across the entire folder. Let's do recursive. Yep. So now you can see that it has done it for both of the files. I think it has done it for both of the files, but I don't see. Okay, it did EC2 module.pf alone. Okay, since we are in the test folder. Okay, let's go one folder back. Let's do Terraform format hyphen hyphen recursive. It did both of these files. Okay, so which means now we have these equal to's aligning in the right way, which is pretty cool. So that's what you do for readability. And again, you can always use Terraform comments. So you can do hash for comments, and you will be able to go ahead and just mention that this is an instance that is created in the US West 2 region. This is an instance that's created in the US East 1 region, and so on. Okay. So these are some of the things in terms of basic Terraform commands. You can always do Terraform, and it's going to give you a list of commands. So you have Terraform apply, you have destroy, you have format, you have console, where you can get an interactive console where you can do some Terraform functions. So let's do Terraform console. And it's going to say that we don't have any suitable provider. Let's do Terraform init. So let it download the provider. We did it within the test directory, but not in the main directory. So let it download the provider. Let's do Terraform console now. And we should be able to get an interactive console where we can just say min of, which is a function. You can just say min. Okay, let me just. Okay, I don't think it's working. Let me just do it once more. Okay, so let's do min of 1, 2, 3. Let's see if it gives us the output. Beautiful. Yeah. So all of the Terraform functions, you can go through their documentation. There are a lot of functions that you can use. There are string functions. There are list functions. A lot of different functions that are there in order to manipulate. You have join function. You have a concat function. You also have replace function. So many are there. But you can always try those functions out in your Terraform console before actually applying it in your code. So let's do an exit. Cool. So these are some of the basic stuff that I wanted to talk about Terraform. Okay. So let's go ahead and learn more advanced concepts in Terraform right now. Okay. So now this is where things are going to get interesting for you guys. Okay. Let's go back to the PPT. Enough of demo. Let's go back to the PPT. Okay. So bye-bye, Gordon Ramsay. Let's do the next one. Okay. So now this is where we are going to learn about two new concepts. These two concepts probably not that many people would have heard about. If you have been working with Chef a lot, you would understand these two topics. But then let me introduce both of them today for you guys to understand. And this is how we do it in the industry. This is how you test your Terraform code. And this is excellent. Okay. So in order for you to get started with Kitchen and InSpec, these are two tools that are part of your Chef development kit or Chef DK. So you have to go ahead and download Chef DK first from this particular link. Anyone who wants access to the slides, don't worry, you can always reach out to me. I'll put my contact number and email ID. You can always reach out and I'll have this slide delivered to you. Okay. So you can go ahead and download Chef DK from that particular link. And then the next thing that you have to do is Chef DK already comes pre-built with Ruby already installed with the executable file. You already have InSpec and Kitchen already pre-installed with Chef DK. But then there are only two other gems. Gems in the sense Ruby's packages, which are called as gems that you have to install. And those are the two gems. Those are called as Test Kitchen and Kitchen Terraform. The reason is because we need some way in order to use a driver. And this driver is going to go ahead and create our infrastructure for us. It's a plugin based architecture. And the driver is nothing but Test Kitchen. And we will learn a little bit more about that. And then we have Kitchen Terraform, because since we have Kitchen in order to go ahead and orchestrate our deployments, like run many Terraform commands in the background, we are going to use Kitchen Terraform, which is a plugin or a gem that is allowing us in order to go ahead and test our Terraform code. So these are the two gems that you need to install, and I have mentioned the respective versions over here. If you're using the latest version of JFDK, which is 4.10.0, if you're using a previous version of JFDK, then you may need to downgrade these two gem versions. But the way that you would install them is, this is the Windows installation command, and below I have given the Linux installation command. For Windows installation command, it goes to C drive opscode jfdk bin. So let me show you that. So let me open up my folder. Let's go to C drive, opscode, jfdk. Within the bin directory, you should be able to go ahead and install both of these gems. Okay. So it may not be here. Yeah, we do have kitchen and all that over here, which is cool. Okay. And then we are mentioning the path of jfdk. Similarly, the path of jfdk needs to be mentioned when you're using a Linux based system. So in a Linux based system, when you install jfdk, it generally goes to opt directory, jfdk bin directory, and you can directly mention both of the versions. So I'll just reiterate that if you're going with the previous version of jfdk, always remember to yourself that you need to find the apt version for test kitchen and kitchen terraform. Okay, so this is how you get started with kitchen and inspec. But now let's first understand as to what test kitchen is and so on. Okay. So test kitchen provides a test harness, which means it just provides you a nice environment in order for you to create your Terraform code, Terraform infrastructure, by just executing your code in a platform that is in isolation. So I'll show you that when we go to the lab, and you'll get a really nice idea. And how it works is, it works based on a driver based plugin architecture. So you can mention your driver as EC2. You can mention your driver as Terraform, which is a community based driver. You can also mention your driver to be Docker and so on. So based on which, Test Kitchen is going to detect your driver and detect your CLI credentials, which I showed you just a moment before for AWS. And then it's going to go ahead and execute a set of Terraform commands in order to create your infrastructure. So it's just one kitchen converge command that does 4 to 5 Terraform commands in the background. And when you see the lab, it will get more clear for you. So more information about Test Kitchen can always be found out when you go to this link of kitchen.ci. But now let's go ahead and understand, how do you in fact write the file for Test Kitchen. So for that, I have a very nice screenshot here. So this is the screenshot of how you do your Test Kitchen components. So this is the screenshot of a file name called as .kitchen.yml, or you can also name it as kitchen.yml. So we have 5 different blocks over here. We have the driver block, the provisioner block, the verifier block, the platforms block, and the suites block. And we will learn about all of these in a second. Let's start with the driver block. The driver block, it's nothing but the Test Kitchen driver that you're using. Just a moment before I mentioned, it's a plugin based architecture, right? Driver plugin based architecture. So you need to specify which driver you're going to use. So the driver that we are going to use for today is Terraform, but you can always go through the kitchen's documentation and find out all of the different drivers that they use, like Docker or EC2 and so on. The provisioner block takes care of configuring your driver and all of the configurations that you provide in your provisioner block. So let's say, for example, you need to configure your EC2 instance in such a way, you can go ahead and probably use the provisioner block. But again, over here, we have kept things simple. We are using the provisioner block of Terraform. Again, over here, the verifier block is also Terraform, because if you go through the documentation of kitchen Terraform, it tells you that your driver, your provisioner, your verifier, and your platforms are all mentioned as Terraform. And this verifier block is very important for you, because you can verify whether your test cases are running or not. And this test cases that we are going to use is on the back end of AWS. So once we create the EC2 instance, we are actually going to test whether that EC2 instance is having a public IP, or whether that EC2 instance has the appropriate tag, or whether the EC2 instance is actually created. So that's the reason why we have mentioned that our backend is AWS and our verifier name is Terraform. And the platform that we are going to use is which platform that we are going to go ahead and write our code in. And the code that we have written is in the platform called as Terraform. And finally, our test suite name, and I'll show you this in the code in a moment. Your test suite name is nothing but the name that you give for your test cases. So if you take a look at this, let me just go ahead and show you that. So where is this default name coming from for the suite's name? The default name is coming from your inspec.yaml file, and you can see over here that for the test that we are going to do, the name of the test is default. So that's the reason why you can see over here the suite's name is default. Okay, let's go to the next one. Let's learn about some of the kitchen commands. So this is where you'll get the idea as to how powerful kitchen is. So you have kitchen create that does Terraform workspace. It does Terraform get for getting all the modules, and it does Terraform init in the background. So it does three commands for you in the background. It creates a brand new workspace, it gets all of your modules, and it initializes your providers. Let's take a look at the next kitchen command. Kitchen converge. It creates your workspace or selects an existing workspace. It gets all of your modules by using the Terraform get command. It goes ahead and initializes your provider and downloads any or initializes any modules that have been gotten uh, previously with the get command. It does your Terraform plan as well as your Terraform apply. So instead of you doing 3 or 4 commands, kitchen converge does all of that for you in just one command. Let's take a look at the next command. Kitchen verify. Now this command does everything that the kitchen converge does, but it also goes ahead and runs your inspect test cases. And in a moment, we will talk about inspect as to how it works. Okay. And finally, the kitchen destroy command goes ahead and selects your workspace, gets all the modules, does a plan, and a destroy of all of your infrastructure. So instead of executing single commands, I'm now going ahead and using a YAML file to denote my configuration. And then we are going to go ahead and execute some kitchen commands in order to create our infrastructure, destroy our infrastructure, and also verify whether our infrastructure was created successfully or not. Now let's go ahead and learn about inspec. So Chef Inspec is an open source testing framework for infrastructure wherein you write human readable language, such as you go ahead and write your testing code in Ruby. It's very easy to understand, and I'll show you that in a moment when we walk through the next lab. It's very easy to understand. It's human readable format. And we are going to use inspec-aws package. So let me show you that in the browser. So if you just go to your browser and then start typing, let me just go back to that. Sorry. Yep. So when you open up a new tab and you start typing inspec-aws, you will be able to land in this particular GitHub page for where you go ahead and take a look at all of the different test cases that you can do on all of the supported services. So if you scroll down over here, you will be able to see that you can do testing for all of these services. And today I'll show you one such example with EC2 instance as to how to test whether an EC2 instance has been created or not with the appropriate tags with that respective AMA ID that you mentioned. Okay, cool. So that's what we are going to use today. We are going to use inspec-aws in order to do our tests. Okay. They have extensive documentation. You can also take a look at the code that they have. Okay. So Chef Inspec makes it easy to run your test wherever you need. You can execute the test by just running the inspec exec command to do it locally, or you can also do it through SSH or WinRM connections for Windows machines and Linux machines, or you can also do it on Docker containers. But today we are going to use a kitchen verify command in order to execute our inspect tests. Okay. So this is how your inspect profile looks like. I just showed you this for a moment. Let me walk you through it. So you have the name. Name is nothing but your test suite name that you give. Then you have the title. This is the inspect profile that we have created for AWS EC2. We have the maintainer, which is me. I'm Akshay PK. I'm a senior cloud engineer. And we have the license. I have copyrighted it to Zeros Initiative, but obviously you can write whatever you want. And the summary is this is nothing but your inspect compliance profile. The version of this profile is 0.1.0 that I'm giving. And the version of inspec that I'm using is greater than equal to 4.22.1. Now, how do I find that? If you guys ask me, how do I find that? Let's go back to the terminal. Once you have installed chefdk through the previous steps that I showed, like in my PPT, you can go ahead and do chef -- version, and it's going to show you the chefdk version. So just give it a moment. It's going to show you that. So we are using the chefdk version of 4.10.0, which is the latest version. In a moment, you'll also see the version of kitchen being used. You'll also see the version of inspec being used because these packages are already part of chefdk. You don't need to install anything extra to get kitchen or inspec. So you can see over here that the inspec version that I'm using is 4.22.1. The test kitchen version I'm using is 2.5.4. So that's how I find out my inspec version, and that's how I populate it over here in my in my profile file. And then we have attributes. Now these attributes are nothing but, let's say for example, you would like to pass some attributes into your test cases, such as you would like to pass the instance ID, or you would like to pass the AMA ID. How do you do this? You do it from your outputs. If you already have outputs, you pass your attributes from your outputs. And once you pass your attributes, you can see over here, we have mentioned that both of your attributes, like for the instance ID and the AMI ID, should be true, which is required. We have the description mentioning what those attributes talk about, and then what is the type of that attribute. You can use string, you can use array, and so on. And now this entire profile of InSpec depends on InSpec AWS, which is directly got from this particular URL from Git. So let me show you as to how to get that. So let's go back to InSpec AWS. We are in this page. You can go ahead and check the releases. So let me just go ahead and take a look at it. So where is the releases? Where are the releases? Okay, I think it's 78 tags. Yep. Okay, cool. This is where you find the releases. And in your releases, you can go ahead and take any specific version that you're going to work with, and you can download the zip file, or you can download the tar.gz file. So over here, we have directly pointed it to the URL of your tar.gz file of your GitHub repo. So what are all the features that are supported in InSpec AWS version 1.229.4? Those are the features that we are using. And obviously the platform it supports is AWS, because we are using InSpec AWS. Okay. So this is in regards to your profile file. Now, if you get your profile file right and your InSpec tests right, this is an example of your InSpec test. This is written in Ruby. It's very simple. The title is AWS EC2 instance, and we are getting both of our attributes and setting it to two variables over here. These are the two attributes that you passed from your InSpec profile file, AWS instance ID and AWS instance AMA ID. And we have both of those attributes over here set into variables. And then we are starting our test cases over here. So we have a control block over here, and we are giving the title that ensure the EC2 instance, after you have created it, exists with the right tags and the right AMA ID. In order to do that, we have written the small test case over here stating that it should actually exist. Its tags should have the value of name and Akshay, and its image ID should be equal to that particular attribute value, which is something that we are passing after getting it from the outputs after it has been created. So many more complex test cases can also be written, but this is a very simple test case that I'm showing you right now, that once the instance has been created, our test cases will run, wherein it will check whether the instance is actually there, whether it has the right AMA ID that we have mentioned through the variables, and whether the tags has the key of name and the value as Akshay. Okay. So having all of these in your mind, like what Kitchen does and what InSpec does, let's go ahead and do a demo. I always love demos and GIFs. Okay. Let's do it. So let's go to the VS Code back again. Let me close all of these. Let me close the module 3 and let's go to module 4. So the module 4 over here is pretty similar to module 3, but it has Kitchen and InSpec already written into it, and it has variables. So let's take a look at our variable file. Our variable file is very simple. It's very, very simple. It has an AMI ID as a variable. It has the instance type as a variable, but we have default values given over here. We have the default value of the AMI ID. We have the default value of the instance type being T2 micro. And then we have tags variable. The type of the tags variable is map. And we have the default value over here, which is name. And the value is TF instance. So this is how you declare variable in Terraform. You have maps, but then you can still get more complicated. You can have a map of lists. You can have list of maps of list. Anything is possible. But then you should have really good programming skills in order to go ahead and iterate through list of maps of lists or something like that, right? But just keep it simple at any point of time. Keep it simple to number, to map, to string, and so on. And even the any type is supported. Object type is supported with variables with Terraform. Okay, so since we have declared our variables over here, let's take a look at the providers file. Now the providers file over here is very simple, man. It's just the region US East 1 that we are going to create our instances. Okay, now let's take a look at the outputs file. Now this outputs file has two outputs over here, one being the EC2 instances ID and the second one being the EC2 instances AMI ID. And the AMI ID is referred from the variable block as var.ami underscore ID. So that's how you kept the variables block as. So let me open up this variables block to the side. You can see it's called as var.ami underscore ID. That's how you refer to a variable. And then for the instance ID, once the instance has been created, we have it as AWS instance dot myec2, which is the instance name, the resource name dot ID. So let's open up ec2.tf on the side. So this is the ec2.tf. We have the AMI ID as var underscore AMI ID. We have the instance type as var dot instance underscore type, the tags as var dot tags. And then you can see over here, the resource name is myec2, the resource type is AWS underscore instance, and we are referring it as AWS underscore instance dot myec2 dot the attribute value of ID. So how do you find out that that's the attribute value? Go back to your Terraform documentation, and the ID is nothing but your instance ID. Pretty cool, right? So now we have all of our code ready, set to go. But then let's take a look at our kitchen.yaml file. And your kitchen.yaml file is something that I showed you in the screenshot. We have Terraform as the driver, the provisioner is Terraform, the verifier is Terraform, but our backend testing is on AWS. Platform is Terraform, and the suite's name is default. And you can see the root module directory is where you have your kitchen code written in, like your isolated code that you're going to test, your module call that you're going to test. And that is within the directory of test/fixtures directory. We also can put in a command timeout over here for 1000 seconds. And the reason why you would need to do this is, let's say that you're creating a database resource. Every database on the AWS side, that's the only annoying aspect, is every database takes at least 15 to 20 minutes to create. And if you have option groups for Oracle, hell man, it takes 36 minutes. So in that way, your kitchen test can probably fail because of a timeout. So therefore, you can also add a timeout or command timeout attribute to your kitchen.yaml, and you can mention it in seconds over here. I've just gone with 1000 just to be on the safer side. Okay. So now let's take a look at our code within the test/fixtures directory. And within this, our code has nothing but an EC2 module call. And now this module call has the name tag as name and Akshay. So let's change this. Let's make one test case fail. Let's change this to my best friend's name, Balaji. And the instance type is being passed as t2.micro. The source is nothing but 2 folders behind. So behind the fixtures folder, behind the test folder is where we have our root module code, which is creating the EC2 instance, presenting us with the output and so on. And the similar way that I showed you as to how to retrieve the output from the base module, you call the module using the module block, the module name, which is EC2, as well as your output block name. So if I just open up the outputs block over here to the side, you're just calling, you're doing nothing but just using the output variable name over here and using the module.ec2 to call it, because essentially this output is reference from your base module, okay? And as well as your AMI ID. So now once you get all of these attributes, when you do the kitchen verify, you're going to get the output of your instance ID as well as your AMI ID, and we are passing this to your inspect profile. So if I take a look at your inspect profile, we are passing these two attributes. And once we pass these two attributes, we are going into our controls folder wherein we have our ec2.rb file. And this ec2.rb file has both the instance ID and the AMI ID after creation being passed from the output. And this test case is going to be executed, where it's going to check whether that instance is created actually on the AWS account. It's going to check whether the tags has name and Akshay. It's going to go ahead and also check whether the image ID is the one that we entered. But now this particular test case is going to fail. Line number 11 test case is going to fail. The reason is because we have the name of the tag as Balaji. Let's test this out. Now let's go back to our command prompt. Let's go into the directory of app4. Okay. So within this directory, let's go into the test fixtures directory. Over here, let's go ahead and do two commands. Let's do kitchen verify, probably just one command that should do everything, because kitchen verify goes ahead and does Terraform workspace, Terraform init, Terraform get, Terraform plan, Terraform apply, and also executes your test cases. So just one command to do everything. So let's do enter. Okay, so it's going to start kitchen test. Okay, so it says there is a small error. The reason is because kitchen.yaml does not exist. Okay, so maybe I think, oops, I shouldn't do it from within the test folder. So sorry. I should go back 2 folders and do it. Yep, I should do it from here. Kitchen verify. Yeah, because it needs the kitchen.yaml or .kitchen.yaml in the root. So now it's starting the test. Let's just wait and see. Okay, fingers crossed. Let's see how it works. Okay, so it says it's doing the default Terraform. It does the Terraform init. It initializes your module. It goes ahead and downloads the AWS provider of 3.6.0. Let's just wait for some more time. Brilliant. It has gone ahead and created a workspace. It's saying that it has validated our Terraform configuration file and the configuration is valid. Let's just wait and see whether it builds our infrastructure, whether it creates an EC2 instance. Beautiful. It's creating an EC2 instance. I'm just giving running commentary. Sorry about that, guys. I'm pretty excited. Okay, so let's go ahead and see if our EC2 instance is created. Yes, there is one instance that's created with the name tag of Balaji. Brilliant. So let's wait for 20-25 seconds. until this EC2 instance is created, and then we will have our test cases running from inspec, and it's gonna fail. Let's see. 10 more seconds. 30 seconds generally it takes for an EC2 instance to get created. Let's just wait for a little bit of time. And this is how you do it in the industry, man. This is how you do it. You have Terraform, you have Kitchen, you have inspec. Now you are set to go for any interviews that ask you questions on Terraform. Yeah. Yep. And the more you talk about this, the more exciting it will be. So now you can see that it's doing the testing. It got two output variables with the AMA ID and the instance ID. Oh my God, it has failed. See, you can see over here, right? It's beautiful. It actually goes and tests with AWS and says, what I am expecting is name and Akshay, but I got name and Balaji. Now let's fix this. Let's fix this. Let's go to our Terraform code. Let's say name is Akshay. Let's save this. Let's do another kitchen verify. Let's do another kitchen verify. But this time it shouldn't do anything to the instance other than just updating the tag. And we should have our test cases pass. So let's just see. Let's just see how it works. So it's verifying the local system again. And again it says this time, oh, because it didn't do an updation, because kitchen verify again just only ran the test case. So what we have to do over here is we have to do kitchen converge to do the actual updation, then do kitchen verify. So let's do a kitchen converge to update the tags. So let's just wait for a moment. It's going to do Terraform init again, Terraform validate, Terraform choosing the workspace, and then it's going to go ahead and modify the EC2 instance. It's going to just say modifying. Please say modifying. Okay, just give it a second. Okay, yeah, so it's saying modifying, and it should say completed modifications. Let's just wait for a moment. Yep, so it has modified, which is pretty cool. So now if you go back to your console, you should be able to see, yes, now it has updated it to name and Akshay. Now let's do kitchen verify. And this time you should be able to see that our test cases all pass. So it's verifying the local system. Let's just take a moment and see. Beautiful. So it says all of our test cases have passed. Now, I'll give you a very nice, interesting fact over here, guys. So people who are working in the DevOps space, people who have CI/CD pipelines created, who are deploying Terraform infrastructure through CI/CD pipelines, have inspec over there. Ensure that you have the best practices in play. Ensure that you're doing your inspect tests for all of the resources that you're creating through Terraform that are supported by inspect AWS. So for all of the resources, I mean all of these supported resources. So if you go back to the code over here and you scroll down, you have a list of supported services over here. Ensure that in your organization, all of the services that you create, please do go ahead and start writing inspect tests and kitchen tests so that you can go ahead and enforce these best practices. So even if suppose one of the inspect tests fails, so let's say that that person is not creating an EC2 instance with tags at all, and your inspect test is failing, you can fail your build and you can go ahead and send back a response stating that the build has failed because of this reason. So that's how you go ahead and create infrastructure through Terraform. You go ahead and use Kitchen in order to do your orchestration of different Terraform commands, and then you have inspec, which goes ahead and tests your infrastructure. Okay. So this is all I had for today, but then let's go to the last section, which is in order to discuss about the HashiCorp Terraform Associate exam. Now this particular exam, it's not that difficult, to be honest, but then you can take a look at the Zealvora course on Udemy for a very basic understanding of Terraform, which will still not help you clear the exam. You can take a look at Brian Crossan's practice tests, and I'm saying this out loud. Even that gives you an idea about how the actual exam is going to be, but it's still going to be a little bit difficult. So you're going to go ahead and study all of these aspects. You're going to study basics of Terraform. You're going to study Terraform providers. You're going to study Terraform provisioners, which we totally didn't discuss about today. You're going to study about Terraform modules, Terraform functions, the comparison between Terraform Cloud and Enterprise, state files, remote backend, security best practices. So these are all some of the concepts that you have to study in order to just, understand Terraform in its entirety before going ahead and attempting your exam. You also have Terraform 12 in the exam, which means you have for loops, if conditions, dynamic blocks, and for each blocks. So all of these are also incorporated into the Terraform Associate exam. So you have to read a lot of content, And if you're a person who is already working with Terraform for nearly 1 year, it should be pretty easy for you if you just sit and study for 3 days. But if you are new to Terraform, I would recommend you to start creating Terraform resources for nearly 3 to 3.5 months. Create your own modules, publish your modules to Terraform registry, or even to your own respective GitHub repository. It'll be useful for everyone else for them to go ahead and use it. But at the same time, you will get a lot of hands-on experience in Terraform. So there is a lot of extensive documentation out there, because any organization that you work for, you will always be going back to Terraform documentation. But then let's say that you get a requirement along these lines. Let's say a recent requirement for me that I got was to create a database instance and then go ahead and execute SQL scripts right when the database instance is created. That's a customized requirement. So how would you do that? Let's say, for example, you have one more requirement. Each and every Terraform, each and every EC2 instance that is created in your AWS infrastructure, you have to go ahead and find the cost or calculate the cost of those EC2 instances, write that to a file, and then upload that file to an S3 bucket. How do you do that? Through Terraform. How do you call CloudFormation templates from Terraform? How do you invoke Python code from Terraform? How do you invoke Ruby code from Terraform? How do you invoke shell script from Terraform? Those are some advanced stuff that you have to start doing, rather than just creating certain resources. And always think about modules. Never ever ever have just one file like main.tf and have all of your resources in that file. Because let's say, for example, you leave your organization, another person comes into your organization, and now he wants to find out, where do I find the VPC in Terraform? There should be a separate file called as vpc.tf. There should be a separate file called as ec2.tf. There should be a separate file called as sg.tf for security groups. So in that way, your Terraform code, when you see it and when you read it, it should be very user friendly. You should have a lot of comments. You should also do documentation. Come on, let's do documentation. Let's do one basic documentation. You can use Terraform docs for that, and it's pretty brilliant. So let me show you that. So I do have one more folder that I'm going to import over here. File, add folder to workspace. I'm going to add the dynamic blocks over here. And within this dynamic blocks folder, I do have a README file over here. And how did this README file get generated for me? How did this get generated? Did I write it? No, obviously not. This is where Terraform docs comes into play. So let me take a look at it. Let me show you. I have a main.tf where I have given some documentation over here within comments. I have given this within comments in main.tf. Let's modify this. Let's say this is RDS parameter group module that anyone can use. I've just added this over here, but this is still not yet reflected in my README file. Let me open this to the side. You can see over here, it's still not yet reflected on the README file. So it says AWS RDS parameter group. Okay, let me probably open this up over here itself. It says AWS RDS parameter group module, but it doesn't say that anyone can use, right? So let's go ahead and do this with Terraform docs. So there is a very nice command. Let me go back to that module, that folder, lab 5 folder. And let's do Terraform docs. And probably I think I just have to refer Google and get that command. So let's bear with me for a moment. I'm going to show you this also in Google. So it's Terraform docs. It's part of a GitHub repo. It's an open source project. You can always go ahead and generate your markdown file, which is your MD file. So I'm going to use this. I'm going to go ahead and use this Terraform markdown as table. You can also do it as a document and so on. Probably let me do it as a table. Why not? Okay, so let's go over here and let's paste that command. And probably just let me do Control C and clear the screen. Paste that command. Okay, let's do dot and let's see if it generates. Okay, so it has generated this, but it has generated this over here, but not written it to the file, right? So let's write it to a file. Let's do output readme.md. And now let's take a look at the readme.md file. Beautiful. Now the readme.md file is updated with that anyone can use from the main.tf. And you also have the module block over here that you specified over here. And you also have the providers set as table over here, the inputs as table. Now let's say that I create a brand new Git repo and I put all of this code over there. Let's do that. And then you will see the power of a README file. So let me go to GitHub. Let me log into GitHub. Let me say github.com. Let me log into GitHub. Let's say new. I'm going to create a brand new repository, Terraform -module -parameter group. Okay. And I'm going to keep it public. I'm going to go ahead and create the repository. So now once I have created this repository, all I need to do is just go ahead and say, just clone this repository, do git init and all that. So let's do all of the git commands. Let me first see if I have git. I do have git, which is pretty cool. Let's see git init. We have initialized an empty repo. Let's say git status. You can see that we have all of these files. We have readme.md, main.tf, parameter group.tf, providers, test and variables.tf. One more security best practice for you guys. Never ever commit your terraform.state file to your git repo. Please don't do that. Don't commit your AWS credentials file to your git repo. You'll be kicked out of an organization to do that when you do that. Okay. So let's also take a look at whether we have any sensitive code over here. Okay. So we do have a terraform.tf state file. So let me go ahead and delete this file. I'm not going to commit this, nor even the backup file. I'm just going to commit everything else. So let's go ahead and do git add dot. Let's just wait for a moment until it has read all of the files. Okay, let's do git. I think let me move it to the top. So git commit -m adding base module code for RDS parameter group. Okay, so it's saying, it's asking me to tell who I am. So let's do these two commands. So let me go ahead and do the user.email is hashpk23@gmail.com and the username is, this is a brand new system that I have set up, so please bear with me before I set all of these. Okay, so now let's do git commit -m. Okay, now let's go ahead and do git remote add origin and let's copy our remote URL. Okay, now let's do git push -u origin master. Now it's asking for my email ID and password one more time. Let me just enter that. Let's see if it pushes all of my files. So it should in a moment. Okay, it's writing all of my files. Just give it a second. Okay, so it has written all of my files, but it's saying some error. What is the reason? You may want to try. Oh, okay. So I think it has gone ahead and added this .terraform folder also. Let us go ahead and delete this. I don't want to add that too because it's a pretty big binary file. So let's go ahead and do git status again. Okay, let's do clear the screen. Let's do git status, git add dot git commit -m removed .terraform folder. Sorry guys, we should generally have this in a git ignore file. I didn't write that. So let's do git push. Okay, so let's do git push -u origin master. Now I think it should work. Just give it a moment. Because that .terraform folder had the AWS binary, right? So that was one of the reasons why it was not able to write it. So this time I believe it should be able to do it. Okay, it says it's written 23 files. Let's go to the GitHub repo and see. Let's refresh. Okay, we still haven't received any. Wait for a little bit more time. I think having the .terraform folder screwed things up because it was trying to upload the .exe file. Yeah, errors do happen. Let's wait for a moment. Or do we have some other code that is, let me just check that. Okay, let me see there. I think it has finished. Okay, it again went to an error because yeah, it's still trying to upload that file. I'm not sure why it's trying to do that. So let's probably try to do another. Let's try it one more time. Let's do git status. Okay, so it's on branch master, but it's not able to commit that file. Let's go to the git repo and see if things are fine. It's still not yet uploaded anything. Okay. Okay, so let's do one thing. So let's go ahead and, okay, this is a trick. Don't ever do this though. So Terraform Labs, dynamic blocks. If I show the hidden folders over here, I'm going to show the .git folder. Let me just go ahead and delete it. Yep. Okay. So now let's go ahead and do git init again. Let's do git status. This time we don't have .terraform file. Cool. Let's do git add dot, git commit -m, added files. Let's do clear screen. Let's do git remote add origin and copy the URL of your git repo. Paste it. Now let's do git push -u origin master. Now this time it shouldn't commit the Terraform executable file. So let's see. It's doing only 9 files. Beautiful. Now it's uploaded it. It just takes a moment to debug. Okay. So now since we have all of our files over here, now you see how your readme.md file is. So now anyone for that matter, who can just go ahead and use this code. So let's go ahead and create a tag. Why not? Let's go ahead and create a new release. And I'm going to call this release as tag version will be release/1. Release title will be db parameter group. And let's go ahead and click out publish release. So now anyone can go ahead and use this specific release in their source call of the module. So since this is a module, anyone can go ahead and go to their module block over here in the source block of their module call and mention this entire git URL of this repo. So they can do something along the lines of copy this. Let me go to my code. So let's go to my module block over here. Where is my module block? Okay. So I can change this source module block or anyone who is invoking this module to have my git URL endpoint with a question mark with the release/1. Now they will be able to go ahead and use whatever code I have written, and all they need to do is just go ahead and pass the parameter group name, the parameter group description, the family, as well as the respective parameters, as well as the tags, and they should be good to go in order to create parameter groups in their respective accounts. How cool is that? So I have written a module called parameter group module, and now anyone can use that just by passing these parameter values. Isn't that beautiful? So this is how you do Terraform when you're working for an organization. Okay. So whatever we have learned today, I'll just do a small recap. We understood the basics of Terraform. We understood how Kitchen and InSpec allows us to do a lot of testing. We uploaded our Terraform code to a Git repository and saw how we generate documentation. And that's by using Terraform docs. You saw how we did our testing by using inspec-AWS. And all of my code, you can always find it out in GitHub repositories. In a moment after this YouTube live, I'll upload it over there. Anyone who wants the PPT can always reach out to me for that. And we also discussed about how to clear your HashiCorp Associate exam for Terraform. Okay. So let me go to questions right now. So let me stop sharing my screen. I'll remove my screen. Okay, cool. So let's see how many questions we have. Okay. Okay, so I just wanted to keep the session for nearly an hour. Okay. Okay. So I think no one has any other questions. Okay, that's cool. Okay, guys, thanks a lot for attending this session. I hope it was insightful. This video will always be there in YouTube in Tamil Clouds channel. Okay. So if at all anyone has any questions, you can always reach out to me. I'll, how do I give my details? So, okay, let me just make a new slide. Let me just make a new slide so that you guys can see my details. So let me just go ahead and create a new slide and name Akshay PK, phone number 63801-93703, email zerosinitiative@gmail.com. Best place for anyone to learn about Terraform or about AWS, zerosinitiative dot teachable.com. Please do go ahead and sign up, log in, and enroll into the course. 40 hours of content for free. We always believe in education for free, so that's why you get 40 hours of content for free. It's smallzerosinitiative.teachable.com. And Balaji will probably put it in the YouTube comments. So Balaji, please do put it in the YouTube comments. Thanks, man. Okay, cool. Other than that, we do have our course on udemy.com, but then it's free for only 3 days. So whenever those 3 days come, I'll always put out a WhatsApp status. I'll put a LinkedIn status and all that. So please do follow us on LinkedIn, and please do subscribe to Tamil Cloud's YouTube channel. You get a lot of content in Tamil over there for AWS and cloud related stuff, even for DevOps. So it's pretty cool channel. Please do subscribe to the channel too. Okay, so thank you guys. If you just let me, I'll just keep on talking. So if there are no other doubts, I'm going to end the broadcast. Thanks a lot. Have a great day. I'll see you guys soon. Bye bye.